In previous presentations, you learned about the pattern of a blood vessel and how this pattern is modified to account for the structure-function relationships observed in the circulation of blood. Our next goal is to understand how lymphatic vessels fit into this equation. Let me begin by posing some questions that will be explored in this presentation. What are lymphatic vessels? What is lymph? How do lymphatic vessels relate to blood vessels? Why are lymphatic vessels necessary? As we explore the answers to these questions, you will learn the critical role the lymphatic vessels play as an essential accessory drainage system to maintain the blood volume by returning the excess fluid lost from the blood during capillary filtration. Let's begin by establishing the problem. It is important to realize that the basic pattern of circulation has an important feature that I did not mention when I initially introduced you to circulation in a previous presentation. That important feature, which occurs at the microcirculatory level, is that the exchange between the capillary blood and interstitial fluid is not equal. Based on factors I covered in the presentation on capillaries, you learned that slightly more fluid is filtered from the capillaries into the interstitial space than is reclaimed by the capillaries from the interstitial space. The net difference leads to an increase of fluid in the interstitial space and a corresponding decrease in the volume of the blood plasma returning to the heart. In the long run, this is obviously not a good thing, as the body would swell with excess fluids accumulating in the tissues, a state we call edema. Continuing unchecked, this would become life-threatening. Unfortunately, this is an inherent problem of a closed circulatory system driven by a pump, and there is no way to avoid this unequal capillary filtration. This then requires a solution. That solution was the evolution of accessory drainage tubes, or the lymphatic vessels. Let's answer the first question. What are lymphatic vessels? Lymphatic vessels begin as small blind or dead-end capillary tubes that are dispersed among the blood capillaries. These hollow, low-pressure dead-end tubes are more permeable than the blood capillaries and occupy the interstitial spaces where the fluid pressure is building as the plasma filtrate from the blood exceeds the fluid return to the blood. Also, lymphatic capillaries have a unique structure that allows interstitial fluid to flow into them but not out. Adjacent endothelial cells of the lymphatic capillary wall overlap each other. When pressure is greater in the interstitial fluid than in the lymph capillary, the overlapping cells separate to easily allow interstitial fluid to enter the lymphatic capillary. When pressure is greater inside the lymphatic capillary, the cells adhere more closely, and lymph cannot escape back into the interstitial fluid. In addition, anchoring filaments extend from the endothelial cells to the surrounding tissues. When excess interstitial fluid accumulates and causes tissue swelling, the anchoring filaments are pulled, making the openings between the cells even larger, so that more fluid can flow into the lymphatic capillaries. Therefore, the lymphatic capillaries become accessory drainage vessels to reclaim the excess fluid that was lost from the blood during capillary filtration, and we call this fluid the lymph. This then answers two of the questions we posed. Next, we must understand what happens with this watery fluid we call lymph. As the excess interstitial fluid is reclaimed and now referred to as the lymph, it flows from the lymphatic capillaries into small lymphatic vessels that are structurally similar to venules. These small lymphatic vessels merge together to form larger lymphatic vessels that are similar in structure to small veins, and these parallel the veins back toward the heart. The lymphatic vessels terminate by forming the largest lymphatic vessels called lymphatic ducts, which join the brachiocephalic veins and add the lymph to the venous blood returning to the heart. This then answers the final questions. How do lymphatic vessels relate to blood vessels? And why are lymphatic vessels necessary? Which we answer as we see the lymphatic vessels eventually join the veins, and in so doing return the excess plasma lost from the blood during capillary filtration back to the blood to maintain the blood volume as it returns to the heart.